section. So first of all, draw the triangular section. So this one it is triangular section. I will change the shape. Okay. So it is width it is B and height it is H. Okay. Width it is B, height it is H. So this one it is neutral axis of this triangular section. This one it is neutral axis. So B it is base of this triangular shape, small b, and H it is height of this triangular shape. So this one it is H it is height of this triangular section. Okay. Just assume one small strip. This one it is small strip. Small strip of its width it is D to E, D and E, D to E. Okay, width it is D to E. So total triangular it is A. This one it is B shape. Sorry, B point and C point. A, B, C point, and width it is DE, and NA it is neutral axis. So write down. Consider a triangular cross section of beam. Triangular cross section of beam of width of base width small b and of base width small b and height h and height h. So consider a strip at a y distance from neutral axis. At a y distance from neutral axis. At a y distance from neutral axis. So D it is a small strip. Okay, it is y distance from. So calculate the width of D. That is width of strip. Width of strip that is DE. We need to calculate DE. Width of strip in bracket DE. Okay. So B by H, we know that by similar triangle, B by H is equal to DE divided by just assume this height it is also small x. So just assume it will be this height it will be small x. Okay, small x. Okay, small x. That is means x. So it will be get DE is equal to bx by h. So this base it will be bx by h. Okay, bx by h. So it will be, I will write down here, D is equal to bx by h. Okay, bx divided by h. Okay, bx by h. So now area of this shaded portion. Okay, area of this shaded portion. Draw the area of this shaded portion. So first of all, shear stress equation. So we know that Q is equal to, it will be Q is equal to SA y bar divided by IB. 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 Okay. I into B. Okay. So yes, it is shear force at section. Shear force at section. Okay, shear force at section. Then it is A y bar it is moment at section about neutral axis. Moment about moment about neutral axis. No, moment of shaded area about neutral axis. Moment of shaded area. Moment of shaded area about neutral axis. About neutral axis. Okay. About neutral axis. Okay. And I it is moment of inertia of triangular section. I it is moment of inertia of triangular section. Moment of inertia of triangular section. Triangular section. Okay. Triangular section. And B it is width of shaded area. B it is width of shaded area. B it is width of shaded area. Shaded area. Shaded area. Okay. So now we are calculated. First calculate area of shaded area. Area of shaded portion. Area of shaded portion. Area of shaded portion is equal to 1/2 base into height. 1/2 base into height. So base it will be bx by h. Base it is bx by h. Bx by h. Bx by h into bx by h into height. It will be x. It will be x. It will be get bx square. Bx square divided by 2h. Divided by 2h. Bx square divided by 2h. Okay. So this one area of shaded portion. Okay. So you can write down this one value. It is also ax is equal to bx square divided by 2h. Bx square divided by 2h. Okay. 2h. Okay. This one it is area of shaded portion. So next it will be calculated y bar. Okay. So y bar is equal to Cg of it is shaded portion. Cg of shaded portion from neutral axis. Okay. So actually, first of all, this distance it is 2/3 of h. This it will be 2/3 of h. 2/3 of h. And this half below the neutral axis it is h by 3. H by 3. Okay. It is h by 3. H by 3. H by 3. 2/3 of h and h by 3. Okay. So we need to calculate Cg of this. Okay. Cg of this. Okay. So from top this one it will be how much? This one it will be from top. Cg of this triangular section from top it is 2/3 of x. So it will be 2/3 of x. Okay. So Cg of this it will be at 2/3 of h minus 2/3 of x. So it will be 2/3 of h minus 2/3 of x. 2/3 of x. Okay. So it will be get common 2/3. 2/3 of h minus x. 2/3 of h minus x. H minus x. 2/3 of h minus x. So this one it is y bar. Okay. So put all this value in equation. So q is equal to, now write down, q is equal to SA y bar divided by IB. S into A into y bar divided by IB. Divided by IB. I into B. I B. Put all this value here. So S into A, it will be how much? A, it will be bx square by 2h. So it will be bx square, bx square, bx square divided by 2h, divided by 2h, divided by 2h into y bar, it will be 2/3 of 2 by 3. Write down here 2 by 3, 2 by 3 in bracket h minus x, in bracket h minus x, h minus x divided by whole divided by I, it is moment of inertia I into x, it is also x, it is how much? X, it will be, sorry, width, it will be b, it will be bx by h, bx by h, width, it will be bx by h, bx by h, bx by h, bx by h. Okay, so simplify this equation. Q is equal to okay. So this b, it will be, this b, it will be get cancelled, this x and this x square, it will be get cancelled, this h and this h, it will be cancelled, these two and these two, it will be get cancelled. So it will be write down final equation. So s into so x in bracket h minus x, h minus x in bracket h minus x into h x minus x divided by divided by divided by I, divided by I, divided by I. So sorry, divided by 3I, 3 into I. Okay, we can write down, simplify this equation. S divided by 3I, s divided by 3I, 3I in bracket x h minus x. To solve this bracket, it is also hx in bracket hx minus x square, minus x square, hx minus s square. Okay, so this one, it is equation number 1. This one, it is equation number 1. Okay, so for neutral axis, at neutral axis, shear stress at neutral axis, shear stress at neutral axis. So put x is equal to here, x is equal to 2/3 of h, 2/3 of h in equation 1, 2/3 of h in equation 1, in equation 1. Okay, in equation 1. Put x is equal to, it will be 2/3 of h, it will be get shear stress at neutral axis is equal to, shear stress at neutral axis is equal to s divided by 3I, s divided by 3 into I. So here h into x, we have put here 2/3 of h, 2/3 of h minus, and x square, it will be 2/3 of h bracket square. Okay, 2/3 of h bracket square, double bracket close, 2/3 of h bracket square. Okay, 2/3 of h bracket. So it will be get s by 3I, final equation s by 3I, s by 3 into, so I, it will be moment of inertia for triangular section at neutral axis, it will be b into h cube divided by 36. bh cube divided by 36. bh cube divided by 36 divided by 36 into so 2/3 of h, it will be how much? 2/3 of h, it will be 2 by 3 h square h square h square h square minus 2 square, it will be 4 by 9 h square 4 by 9 h square 4 by 9 h square. So it will begin. So below write down. So I will write down. So I will note down this equation number 1. So q is equal to s by 3y. It will be x minus x square. Okay. So this equation, it is required for maximum shear stress calculation. Calculate the maximum shear stress. Okay. So now, so 2/3 minus 4 by 3. How much it will be? 2 by 3 minus 4 by 9. It will be 2 by 9 h square. Okay. So simplify this equation. S divided by 3 into bh cube bh cube divided by 36 bh cube divided by 36 divided by 36 into, now this equation, it will be 2 by 9 2 by 9 2 by 9 h square 2 by 9 h square. Okay. h square h square. So this h square and this h cube, it will be get cancelled. Then this 9 3 is 27. So it will be get okay. So 9 1s are 9, 9 4s are 36. 9 4s are 36. It will be get final equation. It will be 4 by 3. 4 by 3. 4, it will become upward side. 4 by 3 into shear force, it is S. So it will be take 2, it is bottom side. That is means 1/2 into B into H. 1/2 B into H, it will be cross-sectional area of this triangular shape. That will be 4 by 3. 4 by 3. 4 by 3. 4 by 3 into 1. Yes, divided by B into D, it will be how much it will be? So you can say it will be Q average. Okay. Q average. Q. Okay. So at neutral axis, QNA is equal to 4 by 3 Q average for triangular shape. Okay. Now maximum shear stress for triangular shape. Now maximum shear stress for triangular section. We need to calculate location of maximum shear stress. Maximum shear stress. Location of maximum shear stress for triangular shape. For triangular section. Okay. So location, we need to calculate location. So differentiate with respect to x for equation 1. So differentiate with respect to x of equation 1 for equation 1 for equation 1 equation 1. We know that equation 1 it will be how much it will be q is equal to, we know that it will be q is equal to s by 3i, s by 3i, s divided by 3i, 3i in bracket hx minus x square, in bracket hx minus x square, x square, x minus x square. This one it is equation 1. So now differentiate with respect to x, that is tq by tx, tq by, so equate tq by ts, tq by tx dx is equal to, dx is equal to s by 3i, s by 3i, 3i, s by 3i, 3i in bracket, in bracket hx it will be h minus 2x, h minus 2x, x minus 2x. So is equal to, equate it will be 0, is equal to 0. Okay, is equal to 0. Okay, so this is equal. Okay, so now h minus 2x is equal to, it will be get 0. Okay, so h is equal to, it will be 2x, 2x. So x is equal to h by 2. X is equal to, it will be h by 2. So x is equal to, it will be h by 2. X is equal to, it will be h by 2. So maximum shear stress it will be occur at h by 2 from the top. Okay, so put x is equal to h by 2 in equation 1, h by 2, h by 2 in equation 1, in equation 1, in equation 1, in equation. So it will get maximum shear stress. So q max is equal to, and q is equal to q max. So q is equal to, equation 1 it is q is equal to, that is s by 3i. That is means it will be x max, q max. Q is equal to q max in equation 1. S divided by 3i, s divided by 3i, s divided by 3i, 3i in bracket equation 1 it is hx, h into x it is h by 2, h by 2 minus h by 2 square in bracket h by 2 square, h by 2 square. Okay, h by 2 square. So this one it is h by 2 square. Okay, it will get final equation s divided by 2i, s divided by 2i, s divided by, sorry, 3i, s divided by 3i, it will be 3i in bracket, in bracket, write down, in bracket h square by 2, h square by 2, h square by 2, it will be h square by 2. So this one it will be h square by 2, h square divided by 2, h square divided by 2 minus h square by 4, minus h square by 4, minus h square by 4, h square divided by 4, h square divided by 4, h square divided by 4 bracket. Okay, final equation it will be get s by 3i, It will be S by 3I, 3I, 3I. So it will be H square by into H square by 2 means it will be get H square by 2. H square by 2 minus H square by 4, it will be get H square by 2. H square by 2. H square by 2. Okay, square by 2. So it will be is equal to S divided by S divided by 3 into 3 into 3 into BH cube by 36. So moment of inertia is BH cube divided by 36 divided by 36. So we'll simplify this equation here. Okay, I'll write down. So Q max is equal to, it will be capital S divided by 3 into 3 into BH cube BH cube divided by 36 divided by 36 into H square by 2 into, it will be H square by 2, it will be H, it will be again H square by 2, H square by, it will be 2. Okay, so H square by 2, H square by 2, square by 2. Okay, so this H square and this H cube, it will be get cancelled. 3 1 the 3, 3 1 the 3, 3 3 the 12. Okay, then anything remaining here, H square by 2 minus H square by 4, sorry, this value, it will be H square by 2, 1 by 2 minus 1 by 4. One by 2 minus 1 by 4. Sorry, this one it is H by 4, H square by 4. So this value it will be get H square by 4. Means this value it will be get H square by 4. Sorry, okay. I will rewrite this equation once again. Okay. So it will be S divided by 2 into BH cube by 36. It will be BH cube divided by 36 divided by 36 divided by 36 into H square divided by 4. So this value to be actually 4 square divided by 4. Okay, 4. So this H square and this H cube it will be get cancelled. So this one it will be 4 to the 8. Can write down, simplify this equation. So 4 to the 8 means 36 divided by 8. 36 divided by 36 divided by, sorry, this will be 36. First of all, simplify this equation. 4 to the 8. The remaining here. Sorry, this one it is 3 value. Okay. And it is will be 3 value. 3i. Okay. Sorry, this one it will be 3. So 3 1 the 3. 3 it will be 12. Okay. So 4 by, so 12 by 8. 4 3 is the 12. 4 by 12. What is 1 minute? What is remaining here? So this 12 and this little bit 12. What is remaining here? X square by 2, x square by 4. 1 by 2 minus 1 by 4. Okay, will be 1 by 4. Just I will cross check this value. BH square. Oh, area remaining. Okay, so now okay, so 4 1 the 4, 4 3 the 12, 4 3 the 12. Okay, it will be get final equation 3s 3s divided by 3s divided by bh, 3s divided by bh, b into h, 3h divided by b into h. Okay, so it will be 3s divided by b into h. Okay, so you can write here 3x divided by b into h. So q max is equal to, so it will be convert. So you can write on 3 by 2. So put one extra 2 here. 3 by 2, 3 by 2 into s, s, s. So area of this triangular shape, it is 1/2 base into height. It will be 1/2 b into h. Okay. So this two it will get, this two it will be get cancelled. So it will be get same here. 3s divided by bh. So 3 by 2, 3 by 2, 3 by 2, 3 by 2, 3 by 2 into s by area. To s by area. That is s by area means it is q average. Q average. So q max is equal to, q max is equal to 3 by 2, 3 by 3 by 2 q average. Q average. Okay. So this one it is for at maximum stress, it will be at h by 2 from the top. Okay. So s by 8 will be q average. It will be 3 by 2. You can write down, it will be in that way. 3 by 2, 3 by 2 into q average, into q average.